This video is going to be on solubility. So what is solubility? And solubility, I'm certain, is a term that many of you have heard of before, and it is the ability to dissolve. And usually we're talking about something dissolving in water, and it's usually a solid. So something that is considered to be soluble is something that can dissolve, or in chemistry we can say it can be in aqueous form. That means that it has dissolved in water. Insoluble means that it cannot be dissolved, or it forms a solid. If it forms a solid, we call that a precipitate. So what affects solubility? The first thing that affects solubility is the type of chemical. Certain chemicals can dissolve and others can't. When you think of sand, we know that sand does not dissolve in water, otherwise we wouldn't have any beaches. On the other hand, we know that salt does dissolve in water. And so it's all based on the chemical composition, whether or not something is soluble or insoluble. There's one other thing that many of you are aware of, and that is that temperature can affect solubility. For example, if you take 2 glasses of iced tea, a cold glass of two glasses of tea, one being iced tea where you've got lots of ice cubes, and the other one being hot tea, and you add 1 teaspoon of sugar to each of those. The hot tea has the ability to dissolve that sugar faster than the iced tea. So temperature makes a difference. When we're dealing with the types of chemicals that dissolve, what we use in chemistry are called solubility charts. And this is a solubility chart that I've asked you to print out because you will be referring back to this solubility chart whenever you're working with any sort of chemicals and solubility. And reading this solubility chart is very straightforward. All the shaded areas are insoluble. So you might want to write on your chart right now, insoluble means does not dissolve in water. All the unshaded parts, the white squares, are ones that do dissolve. And you'll notice that below you have some general rules. And one of the rules, number 1, is probably the most important, and that is all compounds or all elements in the first group, in that alkali metal, they will always form soluble compounds, all right? So anything that's bonded with lithium, hydrogen, sodium, potassium, rubidium, cesium, those will always be soluble. So let's practice. So let's say, for example, I have the chemical manganese chloride, and I want to see if it's soluble or not. So I'm going to either write down S for soluble or I for insoluble, and so I refer back to my chart. And what I'm going to do is I'm going to find Mn. There it is. All right, that was my first, the cation. And then I said chloride. There we go. I believe I said chloride. Yes. Chloride. There we go. And essentially what I'm going to do is I'm going to move across this row until I get to the point where I get to manganese. And it looks like this is my box. My box is unshaded. And so for that reason, I know that it is soluble. Remember, unshaded boxes are soluble. There we go. I'll put an S for that one. Now let's take a look at calcium phosphate. So I'll use a different color pen. Let's do green. So calcium phosphate, I always look for my cations on the top. There's calcium. And then I look for my anion on the column. There's phosphate, and I already can see that I am heading into a shaded region. There it is. This is the box that signifies the solubility. of calcium phosphate, and I can tell that it is insoluble. That means that it forms a solid or a precipitate. So in this case, I'm going to write down I for insoluble. All right, let's go ahead and try the next one. I'll let you stop the video for just a couple of minutes or a minute and see whether or not potassium, that's K, hydroxide, OH, KOH, is going to be soluble. If you got the answer that it is soluble, you are correct. It is a soluble compound. So I mentioned that the type of chemical you use can determine the solubility, but I also mentioned that the temperature has an impact on solubility. And what you're going to notice here is I have a graph, and on that graph you have temperature being the x-axis. As you move across the x-axis, we are increasing the temperature. And as you notice on the left-hand side, this is looking at how many grams of chemical you give to 100 grams of water. So assume you have a beaker with 100 grams of water, and you're giving it more and more, in this case, potassium nitrate. How do I know that it's potassium nitrate? Because it tells me right here. Okay, so in the case of adding potassium nitrate, you notice that the solubility is impacted by the temperature. So let's just kind of do a overview of this graph. You'll notice that you have a green line. The green line shows the saturation point, or in other words, when a solution is saturated. That means that it has reached the max amount of chemical that can go into that water and still be dissolved. So I'll say it again. Saturated means that that is the max amount of grams of chemical that can be added and still be dissolved. An unsaturated solution means that you have more water than grams of chemicals, and we can still add more chemicals and it still will be able to be dissolved. Okay, so unsaturated just simply means you still have the ability to dissolve more in there if you'd want to. A saturated, or often called supersaturated solution, a supersaturated solution means that it is beyond the max of chemical that you put on in there that can be dissolved, and for that reason a supersaturated solution will always have solids left over. And you may have actually experienced this yourselves. Going back to our idea of iced tea or lemonade, you might recognize that you can put in 1 spoonful of sugar and it's still going to be dissolved. But if you want to put in maybe 10 spoonfuls of sugar, at some point that solution just won't be able to dissolve all that sugar, and so you have solid sugar left over. So just as an overview, supersaturated solution, expect to find solid in there because there's just not enough water to dissolve all the chemical. Unsaturated solution is where you can still add chemical, and saturated is where you have the exact amount of chemical that can be dissolved. See it as the Goldilocks, okay? One of the supersaturated, the chair is too big. The unsaturated, the chair is too small. Saturated, the chair is just right, okay? So let's take a look at what sort of questions we can find in solubility graphs. And remember, you'll always be referring back to the solubility graph. So let's say, for example, you're told that you're adding 50 grams of potassium nitrate to 100 grams of water at 60 degrees Celsius. Is the solution saturated, supersaturated, or unsaturated? So what you're going to do is you're going to take a look at 50 grams. There we go. and I have 50 grams right over here. I was told that it was at 60 degrees temperature. Okay, so we'll move all the way to 60. There we are. Is this solution saturated, supersaturated, or unsaturated? And we see that it falls in the region of unsaturated. So that would be our answer. We would say unsaturated. Okay, next thing. How many grams of potassium nitrate do you need to add to 100 grams of water at 40 degrees Celsius to make it a saturated solution? Okay, so we know we are at 40 degrees, and I want to make it a saturated solution in terms of that Goldilocks reference where you hit just the maximum amount of chemical you can put in there and it's still dissolved. And I follow the line up. As I follow the line up, I reach this point, and it looks like at this point that probably it's about 66 to 67. Let's call it 66. 66 grams of potassium nitrate that I can add, and that would be the maximum amount and still be dissolved. All right, let's try the last one. If you add 80 grams of potassium nitrate to 100 grams of water at 30 degrees, how much solid KNO3 remains in the beaker? So we are adding, 80 grams of KNO3. Here we go. Here's my 80 grams. And it is at 30 degrees. All right, so here's where I stop. I want to know how many grams of solid are left in the beaker. Well, it looks like at 30 degrees, it looks like 50 grams can dissolve. I think that has two S's, which means that I have still left over 30 grams that are undissolved. So I have 30 grams of solid. So that will answer my question, 30 grams of solid. Remember, because 50 of them, and I would put S for solid, 50 of those grams can be dissolved. So only 30 are left.